Alright guys, welcome to Math 0314. We are on section 4.8, solving equations using the zero product rule. And what the zero product rule is that any two values that multiply together that are equal to zero, what is the only way you can get to zero here? Well, the only way you can get to zero is either that this x value is equal to zero or this y value is equal to zero. And if you think about it, that makes perfect sense because only a number times 0 gets you 0. So one of the two has to happen. And once either of these occur, we don't really care what's in the other's place, right? So for example, if y is 2 and x is 0, I don't care because 0 times anything is 0, right? If y is 1/2 and x is 0, I still don't care because 0 times 1/2 is still 0. If it's negative 1/2, I still don't care because 0 times negative 1/2 is 0. So that, in a nutshell, is the zero product rule. And we're going to apply this to trinomials here. Not just trinomials, but we're going to start off with trinomials. So let me go ahead and erase what I just did, create some space so I can solve this problem. All right. So what do we do? So the first thing you need to realize is the situation you have. So anytime you see x squared in x, or every time you see a linear with a quadratic term, x squared is the quadratic term, x is the linear term, what you want to do is you want to put everything on the same side. So what you want to do is subtract 12 and create this effect. Okay? From here, we're going to use the skills we've developed in the previous section, and we're going to try to factor this. Okay? So we're going to guess what times what gives me 2x squared, which is obviously 2x and x. Then we're going to go to the back and say what times what is 12. So I'm going to say 6 and 2. Then we're going to check that 2 times 2, which is 4, and 6 times 1 is 6. And we're going to see if we can add or subtract 4 and 6 and get back to the 5 value. Here, clearly that is not the case. When that's not the case, I'm going to draw a line through. I'm going to put 2x and 2 and x and 6. In other words, I switch the position and I try again. So this is going to give me 12. This is going to get me 2. And with 12 and 2, I'm still not getting to 5. That's fine. Draw a line through it. Try again. Okay, so we also know 3 times 4 is 12. So I'll go ahead and put 3 and I'll put 4. Notice, I'm not thinking. I'm just trying values. And this is my recommendation. Just pick a set of numbers, see if you can get it to work. Eventually, you should be able to find a case that works. Now, here's very interesting because 2 times 4 is 8, and 3 times 1 is 3. And if I subtract 8 minus 3, I will get 5. Now, I want negative 5, so I'm going to go ahead and make 8 negative and 3 positive. So 8 will be negative and 3 will be positive. So let me rewrite this. So we're left with 2x plus 3 times x minus 4 equals 0. Now, the great thing about this now is if these are multiplied together, these quantities are multiplied together, these binomials are multiplied together, then I can set each of them equal to 0 and solve them. So we'll subtract 3. We'll divide by 2. And we'll get x to be negative 3 over 2. This next one is a little easier. We just add 4 to both sides, and x equals 4. And these are my solutions. Okay? So, in a nutshell, the only thing we've added is we need to set the equation equal to 0. And then once the equation is 0, and once we factor, we take each bit and set it equal to 0. And that's it. That's all there is to it. So, go ahead, pause the video, and try this on your own, see what you can get. So, hopefully you paused the video, gave it a shot, and were able to figure it out. Again, the first move is, again, to set it equal to 0. So, y squared minus 2y minus 35 equals 0. Then we're going to factor. So we're going to ask ourselves, what times what is y squared, which is obviously y and y. We're going to go to 35 and say, what times what is 35? First thing that pops in my head is 7 and 5. And I want, if 7 is negative and 5 is positive, negative 7 plus 5 is negative 2. And we're good to go. So I can say y minus 7 is 0, y plus 5 is equal to 0, and solve. So y is 7, and y is negative 5. And we are good. On to the next one. All right, 6x squared plus 8x equals 0. Now notice here we do not have a constant term. And in this scenario, and actually in all scenarios, you still always want to do this. You want to look at it and say, hey, is there something that I can factor out of 6 and 8? Well, they're both definitely divisible by 2, so we can factor out a 2. And with x squared and x, we can factor out an x. So we're going to factor out a 2x, and that's going to leave me with 3x plus 4. Again, this is equal to 0, so each bit is equal to 0. So 2x equals 0, and 3x plus 4 equals 0. So now when I solve, I divide through by 2, and x is 0. Here I'm going to subtract 4, divide by 3, and x is equal to negative 4 over 3. And once more, there we have it. Moving right along, we have 9x squared equals 21x. So go ahead, pause the video, and see if you can figure out how to do this. Okay? And assuming that you gave yourself a shot. Now, one thing I want to stress here, you cannot divide through by x. And the reason why you can never do this is you're making an assumption when you do this that x, that's a t. Let me rewrite that. That x equals, or x doesn't equal to 0, right? So remember earlier we've said in this semester, we said if you divide by 0, the value becomes undefined. So if you just divide by 0, you're assuming that x doesn't equal to 0, because if x is 0, it becomes undefined. So that can never be your first move. So let me rewrite it. We have 9x squared equals 21x. And this is why earlier I said what you want to do is subtract 21x to both sides. So the goal is usually that we want everything to equal to 0. And we can play with this. So again, I look at 9, I look at 21, I say, hey, what are both of these divisible by? For sure 3. When I see x squared and x, they both share an x. So we factor out an x, 3x, and we're going to be left with 3x minus 7 equals 0. So once more, set each bit equal to 0 and solve. So this one divided by 3, we're going to get x to be 0. This one add 7, divide by 3, and x is equal to 7/3. So, and once again, you can see if you are having issues with here, what this is probably indication of, you need to go back to some previous sections and work on factoring. Because all we're really doing is factoring and setting pieces equal to 0. Okay, so this one is trying to scare you by having you distribute and whatnot, but apply the same strategies. Go ahead, distribute, move everything to one side, set it equal to 0, try to factor some things out, and see where it takes you. So, if you haven't done so already, you can definitely do this. Pause the video, try it on your own, see where you get with it, and then we'll talk about it. So, going to assume you've done so. Like I said, we're going to distribute. So we're going to get 36x squared plus 18x minus 10x equals 8x plus 25. So before I start moving things over, I'm going to combine or consolidate like terms. So we write this as 36x squared plus 8x equals 8x plus 25. Now something nice happens here. The 8x and the 8x subtract out, and I'm going to move the 25 over here, so we're going to subtract 25. We're going to get 36x squared minus 25 equals 0. Now this is another property we've worked on in the past, and hopefully you remember this one. This one's called the difference of squares. Very, very important. Make sure you know this. So because we can take the square root of both of these, we get 6x and 5. We write it twice. We go plus, we get minus, and this is equal to 0. So now we can take 6x plus 5, set it equal to 0. We can take 6x minus 5, set it equal to 0, and we solve. So subtract 5, And we're just going to divide by 6. X is equal to negative 5, 6. Play the same game on the other side. Add 5. Divide by 6. And there we have it. So, what you can see is this section really is nothing more than a practice of the previous strategies we've learned. So, moving right along, go ahead, pause the video now and try to do number 6 if you haven't done so already, and let's see where it takes us. So, assuming that you've given it a shot, we can see that we're going to be doing a lot of distribution here. So we're going to get 10a squared minus 15a plus 4a plus 4 equals 9a squared minus 6a. Now before I start moving things over to the other side, let's see if we can consolidate terms. So we can definitely put these two together. So it gives me 10a squared minus 9a plus 4 equals 9a squared minus 6a. So we're going to subtract 9a squared. So this will give me a squared minus 9a plus 4 equals negative 6a. And then we'll add 6a to the other side. And this will give me a squared minus 3a plus 4 equals 0. And to finish this off, we're going to factor it. So what times what is a squared? Clearly it's a and a. What times what is 4? I'm going to go with 4 and 1 because negative 4 plus 1 is negative 3. Then we solve each of these. So a is 4 and a is negative 1. Hopefully that's apparent. We just added 4 to the other side and then we subtracted 1 to the other side. And there we have it. So, hopefully that makes sense. Moving right along. More of the same, so go ahead and solve this on your own, see where it takes you. I'm going to assume that you've given it a shot. What's really nice is because they both have x squareds, the x squareds are going to subtract out. We're going to be left with negative 3x plus 1 equals 2x plus 11. I'm going to go ahead and add 3x to the other side and try to keep it positive. So 1 equals 5x plus 11. Then we'll subtract 11 to the other side. Negative 10 equals 5x. And to finish this off, we'll divide by 5. So x is negative 2. And there you have it. So, nice and simple basic equation here, really, to solve. And it was nice because you have the x squareds matching up. So, moving right along, this is where we get to really practice using zero product rule. So realize this. This negative 2 is pretty not important. It's kind of superfluous. So we can divide through by negative 2, and look what happens. It goes away, and we're just left with x plus 7 times x minus 1 times 10x plus 3 equals 0. And because that's always the case, any sort of number on the outside that amplifies the function in some capacity, if you just divide through, it goes away. So you don't really care too much about that. But what we do care about is that each of these little parts here, each of these binomials are set equal to 0. And then we solve. So x is negative 7, x is 1. Here we're going to subtract 3 and divide by 10. So subtract 3, divide by 10. And that's negative 3 over 10. And there you have it. So, not bad at all if you really think about it. So, pause the video. Shouldn't take you more than about 20 seconds to solve this problem. Give it a shot. And hopefully you've done that and realized the only thing you really care about saying is w plus 2 equals 0, 2w plus 1 equals 0, and w minus 8 equals 0. We don't really care about the 3 because if we divide by 3, it just goes away. So all we have to say here is w is equal to negative 2. We're going to subtract 1, then divide by 2. So this is going to be negative 1/2. Hopefully that makes sense. And add 8 and get w is equal to 8. We're kind of at a stage now that you really should be able to do some of this in your head. But if you do need to write out, if you do need to say w plus 1 equals 0, subtract 1 from both sides, get negative 1 equals 2w, and then divide by 2, and get w equals to negative 1/2. If you need to do that, do it. There's nothing wrong with that. I'm just going to try to save some time and space. All right. And if I do need to show more work, please let me know in the comments or email me, and I will. I'll take longer. I'll show each step. All right. Next up. So on this one, it's equal to 0, which is nice because I don't have to move anything around. We can't factor anything out of all of them. So notice that the first term, the leading coefficient of the first term is 1, and not all the terms have z's, so there's really nothing we can factor out. What we said here from the previous sections is that anytime you have 4 terms and you're not sure what to do, you're probably going to do factor by grouping. So we'll pair them, z cubed and z squared, all share a z squared, which leaves me with z plus 3. Notice if I factor in the second pair, factor out a negative 4, you get z plus 3. Negative 4 times z plus 3. So also note when we divide by negative 4 here, I'm changing the sign of both of them. Hence we have z plus 3. This is fantastic because now I can factor out a z plus 3. And I'm left with z squared minus 4. Now you actually have 2 options here. You can leave it as such and you can solve it. Z squared minus 4 does break down to z plus 2 and z minus 2. And I hope you can say why. This is because this is the difference of squares. Remember, if you can take the square root of this and the square root of this, and you have a minus sign between them, it breaks it down to plus or minus, and this is still z plus 3. So now, as such, we can solve each of these. So this would be z equals negative 3, z equals negative 2, and z equals 2. And this is pretty apparent. Remember, we're setting each of these equal to 0, so negative 3 plus 3 would give me 0, negative 2 plus 2 would give me 0, and 2 minus 2 would give me 0. Notice also that if you didn't want to, with this right here, you actually could still solve it just as is. So if you take z squared minus 4 and set it equal to 0, then if you move 4 to the other side, you get 4 equals z squared. And then to get rid of the z squared, we can just take the square root, and z is going to become plus or minus 2. So it would produce the same result. And so it's kind of a choice. I really recommend getting comfortable with the difference of squares and looking out for it, though. I think in general, it's just better practice. Something you really need to make sure you're aware of. But with that being said, number 11 is the more of the same. So give yourself pause the video and see if you can figure this one out on your own. And hopefully you've done that and realize again that we can pair these. So in the first two, I'm going to factor out an x squared. I'm going to be left with x plus 1. In the second two, I'm going to factor out a negative 9. And be left with x plus 1 in the back. Okay. Once more, x plus 1 and x plus 1 match up, so I'm going to factor that out. I'm going to be left with x squared minus 9 in the back part. X squared minus 9 is also, just like in the previous example, is the difference of squares. So I can break that down to x plus 3, x minus 3. This is my preferred way of doing it, and hopefully yours as well. And so we break these down, and we get our answers. So hopefully that's okay. Moving right along. Now we get they're trying to scare you with a word problem, but this isn't. This is just more of the same. So the product. Remember the word product we said back all the way back in chapter 1 means multiply. 2 consecutive odds. So if you have odds, it's going to be x. The second one's going to be x plus 2, and the reason why it's plus 2 is that if we're listing odds, we're jumping by 2 each time, right? So the plus 2 is the gap. So the product of these is 35. So we're just going to have to solve this. What do we want to do here? Let's go ahead and just distribute. We get x squared plus 2x equals 35. Again, when you have 3 different terms like we discussed in the beginning of this section, you want to set it equal to 0. And I feel like we've seen this with 7 and 5. And this is going to be plus and this is going to be minus. So the answer is going to be x equals negative 7 and x equals 5. And there you have it. So, what does this mean? So, What this means, now notice something here. Let's be very careful here. If we say the answer is x is equal to -7, what we're saying is that x is -7, and this is -7 plus 2, which would become -5, and -7 times -5 is positive 35. However, if we say x is 5, this would be 5, this would be 7, and 5 times 7 is 35. So the answer to this is there's actually two pairs. It's -7 and -5 that give me 35, but it's also 5 and 7. So beware of that. There are actually two different pairs, and the answer is not, and you probably will see this on the test as an answer choice if you had a question like this, the answer is not -7 and 5, which is what a lot of people will say. So watch yourself, be careful with that. Alright, so more of the same here. The only thing I'm going to tell you is that just like odds, evens have a gap of 2. So if we're writing consecutive evens, it's x and x plus 2. So that's my little hint. Go ahead, pause the video now and give this problem a shot and see if you can do it on your own. Go and assume you've done that. And hopefully you said is equal to 48 because it says is. Is means equal, and 48 is 48. So again, we factor it out. We move 48 over to the other side, so we'll subtract 48. We're subtracting 48. And now we're going to ask ourselves, what times what is 48, and we add or subtract gets me 6. So hopefully you're saying 8 and 6. We've got to pick values that are close together. 8 is going to be positive, and 6 is going to get negative because I want a positive 2x. And I can't stress enough here that the other important fact, what allows me to do these problems fairly easily and fairly quickly, is the fact that I know my multiplication tables. So if you don't know them, hopefully you're practicing and getting more comfortable with multiplication. All right, moving right along. This question is saying find the x and the y intercepts. So this is actually an exercise of more of the same. Don't get scared by the f of x. F of x is the same thing as y. So let's recall what we've said in the previous videos. The x-intercept is when y is 0, so I'll make y 0. And if you're asking yourself how to solve this, then you just need to look back at the previous problems, right? We said once we set a trinomial is equal to 0, we just factor. And what's going to work here is -4 and 3, because -4 plus 3 is -1. So this will give me x is 4 and x is -3. So what this is saying is that 4, 0 and -3, 0 are going to be my y-intercepts. All right. Now, are going to be my x-intercepts. The y-intercept, remember we always say the other letter is equal to 0, so the y-intercept is when x is equal to 0. So we're going to take the same equation, and now we're setting x equal to 0, which is a very easy exercise, because everything becomes 0 except the constant, which is -12. So the y-intercept is 0, -12. Now something that's very interesting here, and this is actually always true, this value here, in very much the same way as y equals mx plus b, we say b is the y-intercept, the constant here is the y-intercept as well. And if you think about that, that makes perfect sense, because if x is going to be 0, all my x's go poof, they go away. And the only thing that doesn't go away is the constant. And so you don't even have to really do any math to find the y-intercept. The number by itself is the y-intercept. Just make sure you're paying attention to the sign. So with that being said, we got one more problem here. And I gotta ask, what is the y-intercept? And hopefully you said the y-intercept is just 0, 12. Because remember, we just finished saying the constant is the y-intercept. X-intercept, you gotta do some work. So pause the video right now. Try it on your own. Refer back to the previous example if you're not sure what's going on here. And let's see what we get. So, I'm going to assume that you've done that. And like I said, the x-intercept is always when the other letters equal to 0. So x-intercept means y is 0, and we're here. So again, once more, one last time for this section, we're going to factor. So we ask ourselves, what times what is 12? Well, we know 6 and 2 gives me 12, and 6 and 2 is perfect because 6 plus 2 is 8. Now again, since it's equal to 0, we can say x plus 6 equals 0, and x plus 2 equals 0, and once I solve, x is negative 6, and x is negative 2, and those are my answers. And that's it. So, here's the deal. If you really want to test to see if you understand Chapter 4, this is the section to practice. This is really, truly the section to see, hey, do I get Chapter 4? Because if you can do this last section, then you can do Chapter 4. This is, again, once more, this is the culmination of all of Chapter 4. So, 4.8, very important to work through. Make sure you've done the homework in that section. And if you have questions, send them my way. Otherwise, I'll see you in the next video.